showed it in class, all right, and it is taken from the booklet B. Okay, are we ready? Okay, let's read together. Alice and Beatrice were traveling in an air-conditioned car. Both were wearing the same type of spectacles. Okay, Alice put her hands over her spectacles, but Beatrice did not. When they stepped out of the car, there is less fogging on Alice's spectacles than Beatrice as shown. Explain why there is less fogging on Alice's spectacles. And then part B, now this is a 2-mark question. And part B, they ask you explain why their spectacles became clear again after some time. Okay, now this is what we call in the PSLE the application questions, meaning that there's no experiments. They didn't tell you what concept it is, but they give you day-to-day situation, and you're expected to explain what happened using the concepts that you have learned. Okay, and this was last year's 2019 PSLE paper. I think question 1 of the last few questions. All right, and you can see more and more of such questions in the PSLE, lots of application questions. Later on, we are going to take a look at some of the other application type questions. This is generally more challenging for many students. Okay. Now, when you approach application question, the first thing that you need to ask yourself is, what concepts are they testing you in this particular scenario? All right, what concepts? Okay, and you can see that if you know, okay, if you're familiar, I think this situation is something which is not entirely unfamiliar to most of you, especially those of you wearing spectacles like myself. Each time, sometimes early in the morning when I want to get out of my car, right, especially when the weather is quite cold and the car is air conditioned, and or out from the bus, you notice that your spectacles is fogging. Now, first question you need to ask yourself, what is this fogging? What state is it? Is it solid, liquid, and gas? Can you tell me? What is this fogging? Is it solid, liquid, or gas? Okay, some of you say gas, some of you say liquid. Now, if you identify that part wrongly, that's it already. Then you have problem answering this question. Okay, this fog is actually tiny water droplets. They are in liquid state, not gas. Definitely not gas. This fogging, right, that you can see on the spectacles, they are actually tiny water droplets, very similar to mist. Okay, so take note, fog is liquid state. Okay, liquid state. Okay, why you need to know the state? Because when you answer the questions, right, you need to know about the change of state. What change from what state to what state? Okay, and in this question, you notice that this is on the topic of condensation, and part B is on the topic of evaporation. Okay, now this question is slightly more challenging. There are similar questions in the past, but this particular question is a little bit, I think it's a little bit vague, because let's take a look at the question. Both were wearing the same type of spectacles. Alice put her hands over her spectacles. Now, how does she do it exactly? Is it touching the spectacles like this, or cupping, or what? All right, now this is actual PSLE questions. Okay, so I'm assuming that she put her hands over the spectacle means she's touching the lens. Okay, and what happens when she touch the lens of the spectacle lens? Now the lens, the hand is warmer than the spectacle lens. Remember, she has just came out from the air-conditioned car, right? And it is cold, right? But the hands is warm. You know, our body temperature about 36.9 degrees Celsius. So what happens when we touch a warmer object, which is the hand, touches the spectacle lens? There will be heat transfer, correct or not? Now, how does the heat transfer? Heat transfer from a region of higher temperature to a low temperature, meaning that the spectacles, the lens will gain heat. Very good. The lens will gain heat. Now, compared to Beatrice's spectacles. Now, Beatrice did not touch, right? She did not touch the spectacles. So the spectacles lens of Alice is warmer than Beatrice. Correct, right? So what happened? The second thing we need to know, what is this fogging? We know, we learned before that fogging is liquid, right? So where does this liquid come from? So you need to ask yourself, is it from the water around that splashes onto the spectacles? Where does the liquid comes from? Where does the fogging comes from? From the surrounding air. Okay, very good. Not the air conditioning. So we say from the air conditioning, from the surrounding air. What do we call the surrounding air? Water vapor. Very good, Zara. You mentioned water vapor, right? So we know that water vapor is a gas, and then this fog is a liquid. So what is the process called when there's a change of state from a liquid state to from a gas state to a liquid state? Condensation. Well done. So this condensation takes place, right? When does condensation takes place? Because of the warmer water vapor comes in contact with the cooler surface of the spectacles. It loses heat and condenses to form tiny water droplets. So you can see it's not that easy. Okay, it's not easy. It's a little bit confusing, and this is a 2-mark question. Okay, now let's see how to answer. All right. So part A, explain why there is less fogging on Alice spectacles. So this is the answer. First part, you need to explain that Alice spectacles gain heat from her hand, right? Because the hand is warmer. So you need to understand the concept of heat transfer, and hence it is warmer than Beatrice's spectacles. Okay, so Alice spectacles is warmer. So when it's warmer, meaning that less water vapor from the surrounding air, okay, lesser water vapor from surrounding air loses heat and condense on Alice spectacles, and hence less fogging or less water droplets are formed. Okay, let me see some of your answer. Alice spectacles gain heat, okay, warmer. All right, very good. Irhan, Oyet technique, you remember Oyet technique. Okay, Disha, not to worry, you don't have to copy because I've got quite a lot of questions to cover today. Okay, but I've recorded this. Later on when I upload on YouTube channel, then you can take your time and pause and replay again and again. Okay? Alright, can we move on to the next part? Okay, the next part asks, now this next part is slightly easy. They ask to explain why the spectacles became clear again after some time. This part is easy, right? So this is very common. So this is on the concept of evaporation. Okay, concept of evaporation. What happened? Because the tiny water droplets that was the fog which was on the spectacles suddenly disappear. Okay, is it magic? No, right? Because it has evaporated. Why it evaporate? You need to mention the concept of heat gain. Okay, so the water droplets on the spectacles gain heat from the surrounding air and evaporate to form water vapor. Okay, so take note of the answer. You need to be comprehensive with your answer. If not, you will lose marks. Okay, first of all, you need to mention that the fog or the water droplets on the spectacles gain heat. Okay, gain heat. Why? Because the outside surrounding air is warmer, okay, than the water droplets. So it will gain heat and evaporate. Okay, this is a keyword that you need to put. And many students have will forget this. Evaporate into what? Evaporate into water vapor. Okay, that's why it disappears. Water vapor we cannot see, right? Okay. Everybody okay? Any question, guys? Any question? No question? Okay, let's move on to the next question. Now, next question is slightly easier. Slightly easier. Testing you on your concepts. Okay, so I give you about 30 seconds to look through. Okay, let's read together. Mary has a pot of water with a layer of oil as shown below. Okay, based on what you observe from the diagram, state a physical property of oil. Number 1, part A. B, Mary put the pot in a refrigerator which is at a temperature of 4 degrees Celsius. After a few hours, the oil froze and Mary removed it easily from the water. State what freezing means. Number 2, what can you tell about the melting point of oil? Okay, first of all, again, you need to ask yourself, what are the key concepts? Always think of the key concepts. When you answer, you need to, in science, you need to show your understanding of the question. Okay, how to show your understanding? You must state the scientific concepts. Okay, again and again, many times I've mentioned in class. Okay, when you see the word explain, you need to state the scientific concept. Okay, this is not a general comprehension English question, but this is a science question. The examiner wants to see your understanding, how much you understand the scientific concepts or the scientific aspect of the question. All right. Now, first one is very easy. State the physical property of oil. Right? Since it is above the oil, it is on the oil, the top part, the top layer. So we can say that oil floats on water. This is testing you on the concept of buoyancy, right? Some things can float on water, some things will sink in water. So first part is very easy. Now part B. Part B, they ask you, Mary put the pot in the refrigerator, which is at a temperature of 4 degrees Celsius. After a few hours, the oil froze and Mary remove it easily from the water. State what freezing means. This is quite a rare question. Basically, they ask you what is the meaning of freezing. Okay, can you write down? Can any one of you you write down what does freezing means on the chat function? I want to see how you answer. See whether you can get the full one mark or not. Okay, so I say freezing means something is liquid and turn into temporary solid. Liquid turning solid by losing heat. Change of state from liquid to solid. Okay, if you say change of state from liquid to solid, basically freezing is a change of state from liquid state to a solid state. But many students will miss out important point of heat transfer. Remember, the topic on water freezing, melting, condensation, evaporation always must link with the concept of heat transfer. Now, when does freezing happens? It can happen only when it loses heat, right? Only when the substance loses heat. So please remember to mention this part. Okay, so freezing occurs or happens when liquid loses heat and change to a solid state. Okay, many of you mentioned liquid to solid state, no problem, but you forget about the concept of losing. Okay, now second part, what can you tell about the melting point of oil? What's the melting point of oil? Okay, so you can see that at 4 degrees Celsius, we know that the melting point and the freezing point of water is at 0 degrees Celsius, right? But when Mary puts the pot in the refrigerator at a temperature of 4 degrees Celsius, okay, the oil froze, okay? So what can we say about the freezing point or the melting point of oil? Definitely it is above 0 degrees Celsius and in fact above or at 4 degrees Celsius. Okay, so what can we conclude? Tell something about melting point of oil. As the oil froze at 4 degrees Celsius, the melting point of oil is at least 4 degrees Celsius. It could be 4, could be 5. But when the temperature was set at 4, it has already frozen. Okay, but water will not freeze, right? Because we know the freezing point of water is only at 0 degrees Celsius. Okay? Okay, any question, class? No question. Okay, let's move on to the next question. Now, next question is same, taken from last year PSLE. Okay, now let's take a look at the question here. Okay, so I want you to read. I give you about 30 seconds. It's quite a long question. It has 3 parts, part A, B, and C. So I'm showing you only the first part. Ilhan, your favorite question, Okay, let's read together. Now, Ravi wanted to investigate the conditions needed for leaf growth using 3 types of soil. So you know that this is a concept of this is the concept of a fair test, right? Testing about fair experiment. So 4 pots of identical plants were placed in the same area within a garden. The diagram shows the 4 pots of plants after 2 weeks. So you can see here 4 setups, pot P, Q, R, S, and you notice that the type of soil, there are different types of soil. Okay, availability of water. Okay, so straight away again we need to see what concepts are they testing us. Okay, there are several concepts that are being tested. Number 1, the concept of fair test. Okay, secondly, whether you know what is the meaning of change variable, okay, or variable change. Thirdly, you need to know the concept of fixed variable. What is a fixed variable? This one we have done so many times, right? I hope you are able to answer this. Okay, so let's take a look at part A here. State which pot must be compared to conclude about the effect of each variable on the leaf growth. Okay, so they change the change variable here. First thing, when you want to test the effect of the type of soil. So what do you choose? P, R, and S. Okay, why? Because if you want to test the different type of soil, you need to have different types of soil in all your setup. So you have the garden soil, you have the sandy soil, and the clayey soil here. And why not Q? Right? Why not Q instead of P? Can anybody tell me? Why not Q? Why P instead of Q? Anyone? It is the same as P, yeah, but why not Q? Why not Q, R, and S? No water available. Very good. Now you can see here, for setup Q, there's no water, right? Remember, in this particular test, availability of water becomes the fixed variable. So the variable of the water must be the same. So you cannot choose Q as the one of the answer. Okay? Now, let's take a look at let's say you want to test the availability of water. So you choose setup P and Q. Now, P and Q, right? Why? Because one, there's water, one, no water. But the type of soil becomes the fixed variable. FV means the fixed variable. Okay? So the type of soil becomes the fixed variable, right? You must make sure that it is the same. So you cannot use Q and R or Q and S. Even though, right, this is different, got water, no water, but the type of soil is different, right? Remember, when you want to test the availability of water, other variables must be kept the same. Okay, so this is the concept of a fair test. Now let's take a look at, now, any questions, class? Before we move on to the next part? No question, huh? Quite straightforward. Okay, let's take a look at the next question. Next part. Okay, now I give you 30 seconds to read. And then I want you to answer part B. Okay, after you have read part the question, and I want you to answer part B. Okay, let's see who's the first one to answer correctly. Now, it doesn't matter, Arik, you have done this class, this question, this is last year PSLE, probably your teacher may have done this in class. Okay, but so can you write the answer? Okay, only one answer so far. Anybody else? All right. Now, in this question, they are testing you on how to analyze data. Okay, so this data is given in the form of a table. Now, sometimes or many times, they give you in the form of graph. Okay, now graph sometimes can be quite tricky. Table also can be quite tricky. Okay, so you can see here, you must be able to analyze. They ask you, what can Ravi conclude about the effect of fertilizer on leaf growth? Now, you need to, this is what we call a relationship question. What is the effect of fertilizer and leaf growth? So this is the variables, the two variables, fertilizers and leaf growth, similar to here. So basically, you need to tell what happens when the amount of fertilizers increase, Okay, what happens to the leaf growth as you add more fertilizer? That's what they are asking in this question. Okay, and you can see that, okay, Arik said, the more the amount of fertilizer, the less the area of surface area for a leaf after 2 weeks. Now, do you agree, class, with that answer? Now, take note, this is a 2-mark question. Now, some of you mentioned this, as the amount of fertilizer increase, the surface area or the leaf growth increase. Or some of you say, as the amount of fertilizer increase, the leaf growth decrease. Okay, so if you answer that, you either get 0 marks or only 1 mark. Right? You take note here. Okay, there are 2 parts to the reading given to you, to the data given to you. Okay, as the amount of fertilizer increase, right, from here to here, the leaf size also increase, right? You can see 20, 30, 36. But when you increase the amount of fertilizers beyond 10 grams, right, beyond 10 grams, what happened to the leaf growth? Actually goes down. So that means they're trying to say that, hey, when you grow, when you have plants, please don't put too much fertilizer. You need to put exactly the same amount. That's why quite difficult to grow plants. Okay, like for myself, I can never grow plants because always die. Okay, either you put too little or you put too much, right? So you must put just the optimum. All right. Okay, let's see the answer. Okay, so again, key concept here, they're testing you how to analyze data. Very common question in the PSLE. Right, this is from 2019 PSLE. Secondly, you need to understand relationships, okay, between the variables in the question. Okay, so I repeat the answer. As the amount of fertilizers increase up to 10 grams only, up to 10 grams, the leaf growth increases. Beyond, okay, beyond 10 grams of fertilizers, so you can see beyond 10 grams of fertilizers, the leaf growth decrease. Okay, the leaf growth decrease. All right, class? Okay. Now, what about part C? Now, let's take a look at part C. Okay, explain why the results of Ravi's second experiment cannot be used to improve the leaf growth in pot S from his first experiment. Now, can I answer this part C? Okay, they ask you why the results of Ravi's experiment cannot be used to improve the leaf growth in pot S from the first experiment. Now, let's take a look at the first experiment. I'll go back to my slides to the first experiment. So this is the first experiment. Pot S, take note. Pot S, it uses clay soil, right? The first experiment, they use clay soil for pot S. And this experiment uses garden soil. Take note. One is clay soil, the other one is garden soil. Will it be a fair test? Will it be a fair test? Obviously, it's not. It will not be a fair test, right? Okay. Right. So it will not be a fair test. Why? As in the second experiment, it uses garden soil, while the pot S from the first experiment uses clay soil. See? Right. So you cannot compare the result when you use different type of soil. This part is not so bad. The question. Okay, class? Ready? Okay, next we are going to move to some MCQ question. Easy peasy? Okay, can we move on to MCQ? Can, Okay. These are those who, this is fastest finger, you can type your answer, very easy one. Ready? I'm going to show you, 5 seconds. Ready? Go. Okay, what's your answer? Quick. Number 2? You sure? Everybody? Okay, why not number 3? Why not number 3? Can anybody explain why number 3 cannot be the answer? Both are non-flowering. Both are non-flowering, right? Mushroom, no flowers. Fern also no flowers. Why? Very good. Because mushroom is not a plant. It is a fungi. Okay, very good. This was last year PSLE. Okay, easy peasy. Okay, next question. Next question. Another MCQ question. Those who know the answer, please type the answer. Ready? 1, 2, go. Roshan C number 1, Riz number 1, Shawra number 1, Sam number 4, 11. Oh, Joshua number 11. Number 5. Nobody say number 2, number 3. Now please look carefully again. I give you all 20 seconds more. Look again and see whether you want to change your answer. I see there is some of you put 1, some of you put 4. Okay, now look carefully at the question. Okay, the answer is number 4. Okay, the answer is number 4. Okay, I want you all to look carefully again, right? Why the answer is number 4? Someone copied from wrong. Please don't copy others. Okay, you copy others, everybody put 1, you also put 1. Okay, so you must think of your own. So the key concept here, number 1 is photosynthesis, second is respiration. Right? Now, can you explain why the answer is number 4? Now, you see number 1 and number 4, right? The difference is P. Now, Q, no problem, right? There's no argument. Everybody knows that the amount of carbon dioxide will increase for Q. Why? Because black cloth over the glass jar, right? This plant here did not receive any sunlight, so no photosynthesis takes place, only respiration, right? So the amount of carbon dioxide increase and increase. But what about P? Why P? The answer is number 4. Why P is this way? Is there's less light at night? No. Okay, compared to when? Compared to noon. Yes, correct. You see at noon, what happened at noon? Noon, there will be more sunlight, right? Compared to morning and night, right? In the noon, there is more sunlight. Okay? Now, if your answer is number 1, what you're trying to say is that the amount of carbon dioxide in the glass jar will decrease. It decrease all the way until at night. But remember, the amount of light is the most at noon, right? So at noon is where there is the highest rate of photosynthesis. When there's high rate of photosynthesis, more carbon dioxide will be taken in, right? Because during photosynthesis, you know that carbon dioxide is absorbed. That is why there is a decrease in the amount of carbon dioxide in noon, right? As the amount of light decreases when it reaches night, right? So less and less photosynthesis takes place. Correct or not? So again, the amount of carbon dioxide will increase again. So that's why this is the number 4 is the answer. Okay, class? Can You see, not easy, very tricky. Okay, very tricky, and you need to read all options. That's why sometimes when I train you MCQ questions, some of you finish very fast, then everything also wrong. Okay, now the target that you should target is for MCQ question, out of 56 marks, you should aim to get 50 and above. Okay, 50 and above if you want to score your A star or A. Okay, you want to score A or A star, your MCQ you should target 50 and above. Remember, open-ended question is very tough. So you can see that open-ended question not easy to score. Okay, your hope is the MCQ. You must score your MCQ. If you score 30-something, 20-something, please do something about it. You need to practice, you need to read up, you need to analyze, you need to remember, you need to make efforts. Okay, class? Nobody is going to help you during the exam in the PSLE, right? It's between you and the paper. So, and you have to use your thinking process, your experiences, your, whatever that you have learned to apply what you have learned. Huh? Okay, ready? Next question. Okay, can everybody please focus? Nuha. Okay, please don't talk amongst yourself. If not, I'm going to shut the chat function. Huh? Are you ready? Last warning. Huh? Okay, next question. MCQ again. Huh? Those who know the answer, please write down as soon as you can. Ready? 1, 2, begin. Okay, I give you 30 more seconds. Very good. 3, 3, 3, 3, 3, 3, 3. 3. Very good. Huh? All of you get 3 as the answer. Many of you get 3. Some of you get 2. Ilhan, you got 4. You are the odd one out. Okay. Those of you who got 3 as the answer, congratulations. You are wrong. Ha ha ha. Number 3 is wrong. Yes, the answer is number 2. You see? Anyhow do, right? You see, copy. Very sad, Okay, this is a straightforward question. This is primary, the concept that you have learned in primary 3 or primary 4. This is a lower block concept, right? Which is on the topic of matter. Okay. Now, Harry, can you explain why the answer is number 2? Air can be compressed. Yes, correct. Okay, what is the concept being tested here? Number 1, the concept of matter and the properties of air and water, right? Okay, so we know that water is liquid state, right? Liquid has a definite shape and no definite shape, definite volume, and cannot be compressed. But air, no definite shape, no definite volume, and can be compressed. So what happened when, okay, you can see initially 15 cubic centimeter of water. So using the pump, 5 more is added, right? So plus 5, right? Plus 5, so you have 20. Okay, you have 20, yeah? So I add 5. Now, you have 20. Right? You have 20. And what is the capacity of this container? The capacity is 35 plus 15 is 50. Okay, the container, the capacity is 50. So, now you have 20. Now, water we know cannot be compressed, right? But the balance here, the space for air, left is 30, right? And since air can be compressed, no matter whether you add air or you remove some air from here, it doesn't make any difference because the final amount of air in the container, which is this air space here, will be left with 30 cubic centimeter. Okay, guys? This is a very common question, and by now, P6 students, you should get it correct. Unless you're a P5 or P4 student, okay, understandable. By P6, you should get it correct by now. Okay? So again, I'm going to repeat for those of you who still don't understand. Okay, so the total capacity of the container is 50 cubic centimeter. How do you know? 35 plus 15, right? Then after adding 5 cubic centimeter of water, so water here now become 20 and the air space here will become 30 cubic centimeter. Now since air can be compressed, so even if you add additional 30, right, it will still be additional 10, it will still be 30. Correct or not? Okay, so that's why the answer is number 2. Okay? Okay, let's move on to the next question. Are we ready, class? Next question. Now, next question, easy peasy, MCQ. Ready? Go. Remember, don't copy others. One put 4, everybody put 4. Some put 2. Some put 2, some put 4. Okay, this one is quite easy. The answer is, are we ready? Okay, first of all, let's think about the concept. What is the concept? Right, the concept here is about factors affecting the rate of evaporation of water. What are the 3 factors that affect rate of evaporation of water? Right, number 1, the temperature of the surrounding. Right, number 2, the presence of wind. Number 3, exposed surface area of water. That is the 3 things that you should know based on your syllabus. Humidity, all this is not in your syllabus. Okay, then we take a look at all the condition. Now, some of you put number 2 as the answer. Let's take a look at number 2. Number 2 is B. No wind in the sun. Okay, number 4 is the answer. In the sun, yes, this part no problem, but this one got no wind and this one windy. Which one water evaporate faster? Got no wind or windy? Windy, right? So we know because the presence of wind will increase the rate of evaporation. Okay, so that's why D is the answer, because you have to water pot D most often. Okay? Can? Science very bad? Okay, no problem. I mean, you have to make an effort, right? So science, yes, it's not easy to score A star, but it is easy to pass. Okay, like unlike maths, maths some of you are struggling even to pass. But for science, if you get high marks or good marks for your MCQ, you can pass, because MCQ is 56 marks. And if you get, say, 40 plus, you just need to get additional few marks in the open-ended question, you can pass. Right? But if you are aiming to get high marks, A star or A, then there is something very different. Especially A star is very challenging, right? In fact, many of the better students, easier for you to get A star for maths compared to for science, right? Because a lot of the questions is very subjective. Okay? Now, let's move on to the next question. Now, this question is very, I would say, very unique, right? Because from last year PSLE, they ask you to draw, this is on electricity, they ask you to draw, but they ask you to draw, in a strange manner. Okay, are we ready? Right. Okay, so this is electricity question. Electricity, you all learn in primary 5, right? What is the concept? Tested. Okay, about electrical circuit diagram, parallel and series arrangement. Okay, I give you clues already. Okay, I give you 1 minute to do. All right. Diagram 1 shows the front view of Kenneth toy ambulance. Okay, he sets up an electric circuit in the toy using bulb P, a sound box S. Okay, and batteries as shown below. All the circuit's components are working. When he closes the switch, the bulb does not light up and there's no sound. No sound doesn't light up. Draw a circuit below to correct the mistake. Can you tell me what is the mistake? Can you write it down? You can draw. You have piece of paper. You can draw, but you can tell. You can tell us, share with us also. What is the mistake? Okay. Can you be more specific in your answer? Right. Don't just tell me the bulb. What about the bulb? Something wrong with the bulb? You don't know? Switch is closed? No, you cannot mention about the switch. Because why? He say when he closes the switch, that means this will be closed. Okay, this part, nothing, no problem. Okay, someone say the bulb. Now, can you elaborate? What about the bulb? The bulb is not placed properly? Yeah, how? Why? Okay, someone say about the battery. There are 2 mistakes here. 2 mistakes. Number 1, the connection of the bulb. Now, can you see the bulb? this wire, both of the wire is connected to the tip of the bulb. Right? We know one you must connect to the tip, the other one you must connect to the metal casing. Correct or not? So if let's say this like this, right? So the other one must be like this. Okay, so there's one mistake. Second mistake, some of you spotted battery. You know, what's wrong with the battery? What's wrong with the battery? Can you share with us what's wrong with the battery? Correct, there's a problem with the battery. Nothing. Direction of the battery, both on the same size, correct. You see, this battery, right? This is connected to the ends. So both ends are connected together. Can or not? Cannot, right? Should be one positive, one negative. So this part here should be connected to here. Or you switch the battery the other way around. Right? Okay. So then you must draw. In the PSLE, they ask you to draw. Okay, they ask you to draw. So how to draw? How to draw? Like that, lor. Okay. Then they give you like this, right? So you need to draw the wiring. One is the casing, the other one touching the tip, and then the battery. You must turn one of the battery. Okay, you must turn one of the battery. Now here, this is the strange part. They did not ask you to draw in electrical symbol. In a circuit, in symbol, using symbol, because the battery here they show in full battery, so you draw the same wise. Likewise, the bulb here also is not in the standard circuit diagram, the normal bulb, right? But anyway, they draw for you. Okay, so this is how you should draw. This is for part A. It's a 2-mark question. So it's not easy. Very rare that they ask you to draw. But this was from last year PSLE. I don't know, maybe this year they come up again. Okay, so I got a few of my top students. They were stuck with this question. Okay, they were quite intrigued. Okay, with this question. Now let's take a look at part B. Kenneth adds 2 other bulbs for the headlights of the toy. When he closed the switch, all 3 light bulbs will light up without dimming bulb P. Without dimming. So what does it mean? Now, can you share with us how to draw the connection of for the 2 bulbs? How to draw? Parallel. Okay, somebody say parallel. Correct, not parallel, guys? Must it be parallel? Many also parallel. Those of you say parallel, wrong. Parallel is wrong. Why wrong? Okay. It should be connected in correct. Okay, sorry. It should be in parallel. Okay, it should be in parallel, not series. Okay, why? Why must be in parallel? Okay, because they say that without dimming bulb P. Okay, so this bulb cannot. Okay, without, you would not. Okay, here the keyword here is without dimming. Okay, without dimming means that the amount of electricity that flows will be the same from this way or this way. Okay, so that's why you must arrange it in parallel. All right, not in series. Because if in series, if you have 3 bulbs, right, the amount of electricity that flows will have to be shared. Then it will become dimmer. Right, and here in the question, you do not want it to become dimmer because they say that without dimming. Okay, not dimming the bulb. Okay, without dimming, so it must be in parallel arrangement. So you can see here, this is parallel, right, with this bulb. Okay, that's why it is not that easy. Quite tricky. Okay. Okay, are we ready with the last question? Last question. This is open-ended question on magnets. Okay, ready? Okay. All right. This is on magnetic force. Okay, are you ready? Now, Leela placed a magnet on top of a balance as shown in diagram 1. Okay, so there's a magnet here. He placed a magnet on top. Okay, there's another magnet here. She brought object A close to magnet as shown in diagram 2. State the object A. Now you can see that the balance or the spring balance, the electric balance, there's an increase in the reading, 60 and 68. Now what is the reason? Is it because it became heavier? Okay, please focus, Ilham. Okay, I think I'm going to switch off. Okay, I want you to focus. Okay, so then you need to think, what is the concept they are testing you? Number one, the properties of magnet. Okay, now magnets has many properties. One of the key properties is it has two kinds of force. Number one, magnetic force of attraction. The other one is magnetic force of repulsion. Okay, and you need to know when magnetic force of attraction happens and when magnetic force of repulsion can happen. Now, magnetic force of repulsion happens only when you have two magnets with like poles. Okay, like poles either means north-north or south-south, then it will repel. That's magnetic force of repulsion. Okay, magnetic force of attraction, two situations. Number one, when you have two magnets, okay, with unlike poles. That means north-south. Okay, and second situation is when you have a magnet with a magnetic material. Example, iron. You have magnet and iron, there will be magnetic force of attraction. Okay. So here they ask you, why does the reading in the balance increase in diagram 2? Very easy, right? Because since this is a magnet, we know that this is a magnet, so there is a magnetic force of repulsion. Okay, this one goes up and this one goes down. So example, this must be like poles. Let's say this is north pole and this is also north pole. So when you have north and north pole like poles, it will repel, right? When it repels, the magnets at the bottom part will be pushed further down. That's why the reading here is 68 instead of 60. Okay, so the magnetic force of repulsion between the two magnets pushes the lower magnet downwards. Right, remember this part here cannot be pushed outward because it is stuck, okay, on the clamp on the retort stand. But the one at the bottom will be pushed further down, right? That's why causing the reading in the balance to increase, right? That is for part B. Now let's take a look at part C, part C. Now I'll on back the chat function. I want you to write down the answer for part C. Okay, ready? Okay, can you write down the answer for part C? Leela replaced object A with an iron bar of the same size. Okay, and which reading PQRST below is possible on the balance? And explain your answer. Okay, explain your answer. Okay, we just put the number, the alphabet, not enough, you need to explain. Harry, I want to see your answer. PQRST, there, here. PQRST, this is the reading. When Leela replaced object A with an iron bar, right? Iron bar, so what will be the reading on the spring balance? Okay, can you explain? If you just write, let's say the answer is Q, and then you write Q as the answer. If you do not explain or you explain wrongly, you get 0 marks. Remember, the explanation is very important because they want to know whether you are just guessing or whether you know the scientific concepts. Okay, Izzat put P, the iron bar got attracted to the magnet. Okay, Disha, very good. The answer is P, yeah? But can you explain why the answer is P? Nur Shahrin, right? P is a magnet. P as the magnet will attract. Okay, you see, this is a magnet and object is an iron bar, right? So when you have an iron bar and a magnet, there will be magnetic force of attraction. Okay, so magnetic force of attraction, that means this magnet will be attracted. Okay, will attracted to the iron bar, right, on top. But since the iron bar is stuck here at the clamp, so the magnet will try to go up. So that is why the reading in the spring balance here will be lesser than 60. Okay, not the spring balance, the electric balance will be lesser than 60. Okay, so you can see here, that's why 50 P is the answer. Okay, that's why P is the answer. Okay, so let me explain. So the answer is P. Why? Because the magnet will be attracted to the iron bar, hence resulting in the lesser downward force on the balance. Okay, and in part B, state a variable that Lila must keep constant when comparing A and iron bar. Okay, obviously the distance between the magnet and the iron bar must be kept the same. Okay, got that, class? ASAP? Is it okay, everyone? Okay, we are left with about 5 minutes. Okay, so this is the last question, and I give you 5 minutes. Do you have any question related to what we have discussed? Any questions?